Guys, I am presently renovating this beautiful Class C 1985 motorhome. It's on a small G3500 GMC van, Vandura, single wheel, not dually. This little truck weighs 3,100 kilos. I'm in Canada, so our plates are registered in kilograms, but I could do the transfer for you if you're in pounds. But yeah, let me show you something and explain you the purpose of this video, because I did this a few times in some RV trailers, and people ask me how to do this. So by the way, it looks very nice. It was in excellent condition when I bought it for its age, but I'm going through a major change in this. I'm trying to leave it as vintage as possible. Even the flooring is original, and I'm keeping it like that because it just looks beautiful to me. Me and my girlfriend, we changed the wallpaper, and we chose a vintage type wallpaper. So yeah, all the windows were removed. Very basic water infiltration here. Nothing on this window, nothing on this window, and major infiltration on this window that was covered with a metal plate from the outside, and I took this off and removed the window, and I replaced about a 3-foot section of 2x2 over there. But besides that, no water infiltration. Very good quality RV for 1985, and the bathroom was completely redone. It's a wet bath, but I wanted to have a small rig, and this is what happens with small motorhomes. Yeah, the purpose of this video is that you can see the fridge. It's a 7.3 cubic feet regular home fridge, and there was the fridge that was there was working, but it was very small, like 3 cubic feet, and it's too small when you travel a lot. I wanted to have something bigger, and the electrical part of these three-way fridge are a heating element, and on a home fridge it's a compressor, and it uses far less electricity. So I installed 400 watts of solar panel on the roof. I don't know how to pronounce it exactly, but on the roof of this RV there's 400 watt of solar panel. Solar cables are coming in here. There's going to be a charge controller, and DC line will go to lithium battery. There's going to be a 2000 watt sine wave inverter. Now the trick is, when you work like this, you have an inverter, and sometimes you're connected to the shoreline, to the grid, on a camping or something like that. You want to use the grid power. So I'm going to show you how I use a simple relay to make my fridge go on the AC power or on the inverter automatically, without having to change any plug or move any switches. So if you're in a camping and you're connected to the AC power of the camping, and you go for a 4, 5, 6 hour hike, and suddenly power goes out, or somebody accidentally unplugs your rig or something like that, then your power will switch automatically to your battery on the solar panel. So that worked very good for me in the past, and a lot of people ask me how I did this. So I'm gonna put you a small sketch, a small diagram. Of course, you need to know a little bit about electricity, and if you have no knowledge at all about electricity, don't attempt to do that. By the way I secure the fridge, all these little fridge, very cheap, like in Canada, $369 for a brand new fridge. You always have the choice to put the hinge on that side or on this side, and you can open the door either way. So for my rig, it came assembled the other way, so I flipped the hinge side, and now I have it opening the proper way. But having said that, you always have on the top the place where you can bolt the hinge. So if you hinge it on this side, what I do is that on the other side I use these holes and these threads in the fridge, and I build a small metal bracket that I bolt to a solid place on the rig, on the motorhome, and on the back end of the fridge from behind I've got 2 screws that goes into that floor, so that fridge is going nowhere when I'm traveling. It's very strong. The only thing I might have to do is have some kind of bungee or rubber attachment here to make sure the doors won't open, but a small motorhome like this moves far less than a travel trailer, and I don't think I will need this in the motorhome. So enough talking, and I'm going to show you a small diagram of the electrical assembly I'm going to do for this electrical circuit. Okay, let's see how this works and what you need in order to complete that circuit. You need a small relay like this. I got this from Amazon. I think it's less than $10, something like $8 or $9, maybe 12, I'm not sure now. It comes with a little piece of a DIN rail. It's more of an industrial type mount than something for a chassis, but it's a regular relay that hooks up to this base, and it gives you the wire connection. Some of them are with lugs that you crimp a lug at the end of the cable and you push in place, but I like this, so you save all the lug installation on the electrical wires. Here's the small circuit. For those of you who are familiar with electricity, it's going to be very simple. You get your RV transformer and breaker panel. Usually in an RV you get 12 volts and 110 volts, here in North America at least. And you get your breaker for your inside 110 volt circuits, and you get your fuses for your 12 volt circuits, and this has a battery charger and so on. But I omitted all of this for clarity. I only draw one 15 amp circuit coming out of that RV box. You have to identify the cable that goes to the outlets where your fridge is going to be connected. In my RV, there are 3 outlets in the fridge on that same circuit. That's no big deal. The fridge is not using a lot of power. It's about 110, 120 watts when it's running. There's a 700 to 800 watt peak when it starts, but that runs for a few seconds. So that's okay, even if I have other things connected to this. This is how I hook up the relay. You identify that cable, you cut it. I omitted the ground wire too, but of course the ground wires have to be connected together. It's a floating ground in an RV, so somehow you have to attach it to the vehicle, but usually it's done here. The ground is already attached here, so you need to make the ground continuity to that cable. On a relay, you get a normally open and normally closed circuit. So that means when there's no power to the coil, the blades contact one side. This is a double pull, double throw, so it means it's 6-pin relay. You get two center pins, and you get a normally open and normally closed contact. So you hook up this line to the normally open side of the relay. The normally closed, so it means that contact is permanent when the coil is not activated, goes to your inverter. So your battery will feed the inverter, and the inverter will come to the normally closed side of the relay. And then you get the coil, which is activating the relay on one side, or is going to release to the normally closed, and then when it's activated it goes to the normally open side. And you get your common, which is your AC line. So the cable that was cut from here, this was at the beginning a single cable, is now going to the common and feeds your AC line. Now what you do on the normally open side, you use some small jumper wires and you connect the coil. Of course, that relay has to be with the, I don't know if you can see, but it's a 110 volt AC coil, because if it's a 12 or 24 volt coil, it's not going to work. It's going to blow every time you're going to apply 110 volts. So when there's no AC power coming from this transformer, the inverter is feeding 110 volts through the normally closed, and it feeds the connection or the plugs in your RV. When you get AC on coming to the box, this will trigger the coil and it will flip on the normally open, and now the 115 volts will go to the common and feed the refrigerator. So what is nice with this is that in any circumstances, if you're not in your RV, if you're connected to an AC line and this goes off, breaker trips or whatever, this relay will kick in and your inverter will feed the fridge. So anytime you unplug and you go on the road and then go from a camping to a camping or whatsoever, your inverter will feed your fridge without any problem. In the case like myself where you have solar panels charging the battery, and if it's a travel trailer or a motorhome, when you run the engine, you have the alternator running, it also charges the battery. I never had any issues of depleting a battery. Actually, a 100 amp lithium battery will probably last like a day and a half on running a fridge without any charging of the battery. So with the solar panel and the driving, there's absolutely no issues. So that's the diagram. Now I will make a small video of how I do all this install, so you can see how it goes in my personal installation that you can clone to your RV trailer or motorhome. Okay, let's see now how this will translate as far as installation into the vehicle. One thing to note is that these old RVs at the time only had lead acid batteries, and the house battery was located outside in a small compartment right beside the driver's seat underneath the floor of the vehicle. And since I'm going to use lithium batteries, I don't want to have the batteries outside, I want them inside. So one of the things I had to do is reroute the charging cable from the alternator and get another cable from the box to get the battery connected to the 12 volt circuit of the distribution box. So this is where I stand right now. This cable is from the alternator. There is a diode box at the front in the truck, so the alternator can send current to charge this battery and the truck battery, but there's isolation between this battery and the truck battery, so the house battery cannot send any power back to the truck for starting or anything like that, and vice versa it's the same. So they're both isolated by a bridge of two diodes at the front, big box with two big diodes in it. This cable is the 12 volt circuit going to the 12 volt box here, a 12 and 110 volts distribution box in the RV, and this serves two purposes. Once the RV is connected to the electrical outlet outside, the relay kicks in and current is coming from the charger to the battery to recharge the battery. When there's no power coming in, no 110 volt power coming into this box, the relay kicks on the other side, and then the battery is connected to the 12 volt circuits to feed the 12 volt requirements into the RV, so lights, fan, water pump, etc. So that cable is back and ready to be used. And I have this black cable here that goes outside through a hole here and is grounded to the frame. So it's like a floating ground in a vehicle like this. So everything goes to common, and that's this cable. So for the purpose of this install right now, I don't have my lithium battery, so I will use that lead acid battery, but it's going to be replaced by lithium battery for the final install. So what I'm going to do now is that I identified the circuit that feeds 110 volts to the plug behind the fridge, and I will cut this cable and I will install the relay as I mentioned and I showed on the diagram. Okay, the relay is now installed. Hopefully this is going to be clear enough for you to see. yeah, that cable here is from the breaker, so it's on the normally open connection. This is on the normally closed position that will go to the inverter, and this is the common, which is the actual line, AC line going into the RV. So this really will be attached on the DIN rail and attached to this plywood piece here, and I have a piece of wood that goes on top here and hides all this, so only this cable from the relay will come up to the inverter. I'm going to show you this next. So I put back the piece of wood that covers the heating duct and the electrical wires in the back, where I showed you the relay where it's installed. Now this inverter will be screwed to this side here, and I have the electric wire coming from the relay to the inverter. So the last thing for me to do is to hook up the battery to the inverter and test the whole system. One of the reasons I chose that inverter, beside the fact that it had good reviews and it is quite inexpensive for 2000 watt, but I like the fact that it had a terminal block onto it for attaching a line instead of only AC wall outlet connectors. I prefer this for a setup like this, where it's more like a permanent thing than a portable thing. So let's hook up the battery and do the testing. Everything is set up now for this test. You can see the inverter is turned on. You can see the screen, 12.8 volt input, 60 Hz, 123 volt output, and 0 watt. Right now the inverter is on, but is not connected to the line because I have my main breaker on here, and it's the AC coming from my house, from my home, is feeding the truck and running the fridge. I don't know if we can hear the compressor, but the fridge is actually running. It's warm, just been running for a couple of minutes. So what I will do is that I will shut off the main breaker, which will cut the power to the AC line. So it's going to switch the relay to the inverter side, and the inverter is going to take over and keep running the fridge, and I will be able to show you the consumption of the fridge on that AC line. So let's do that. Main breaker is here. Shut off the main breaker. The fridge is still running, compressor is still running, and you can now see on the inverter that the power is around 132 watts. So it's instant transfer. It goes automatically. The fridge doesn't stop, nothing happens, and that's just a perfect setup. Now I will kick in the AC line again, like this. Fridge is still running, no issues, compressor is still running, but now you can see on the inverter 0 watt, so the battery is not feeding the power to the fridge right now. It's the AC line. So very easy setup, allows you to run a regular inverter without any transfer switch on the inverter, to run it with the AC line from your RV, and switch back and forth on battery and 110 volt for your appliance, especially for fridge where you don't want this to miss any power. Hope you like this video, and if you have any comments, don't be shy to write me your comments. Have a good day.